So today's video is going to cover the scientific method. Just as a recap, last video talked about the basics. So what is physics? What is matter? What is our main goal as scientists? And our two types of observations. So now our next big basis is really the scientific method. What are the steps on it? Are there steps that are more important than others? Does it always have to be done in that order? Questions like that. So the first and main step of the scientific method is ask a question. Really, the only way our world has progressed to where we are right now is because of the questions we've asked. So after asking this question, our next step is to do background research. This has kind of a dual benefit. The first benefit is you might find out you've asked a question that's already been researched and answered. So you don't need to go through the steps of doing a new experiment, setting the parameters, anything like that, because it's answered for you. The second part is that you really oftentimes need some base information in order to define your question, define the problem you really have. Some questions are just way too broad. You need to kind of narrow it down, figure out what explicitly are you wondering about? What do you explicitly have questions about? What do you want to experiment on? So after doing that background research, you are going to form a hypothesis. Now this really is a crucial step because forming a hypothesis can sometimes be a little bit difficult. At the most basic definition of what a hypothesis is, it's an educated guess. But really, most importantly, it's a testable question or guess with parameters that make sense. Now, I'm going to write this down and then kind of expand on it a little bit more. So, I'm going to just give you kind of a really basic hypothesis. I could have a hypothesis that is people who go to the gym are stronger. Cool, but how is that really testable? What are my kind of parameters? What am I looking for? What are my outliers? Things like that. So it's true, you could go to the gym and get stronger, but you could also go to the gym and just hang out with your friends. Or you could go to the gym and do every single exercise with poor form and literally just hurt yourself and never get stronger. So what you want to do is make sure that what your hypothesis is testable and that you've given your experiment a way to track that. So to define that a little bit more, I could say people who go to the gym and dedicate 30 minutes to active movement get stronger. You can test that. You can have a group and put them in a gym for 30 minutes, have them move correctly, lift correctly for 30 minutes, and see in the future if they get stronger or they don't. The one thing that a hypothesis cannot be is an opinion. So if you ever wondered what the best pizza topping ever is, we're not going to be able to figure that out via the scientific method because that's a straight up opinion. There is no hypothesis about that because any hypothesis formed is an opinion. For example, I would personally say that mushrooms and olives are the best pizza topping. But my fiance might say, nah, pineapple and ham is the best pizza topping. That's not something you can solve. It's not really an educated guess. It's just us giving opinions and assuming people will fall one way or the other. So I'm currently using this format of videos for learning because I came up with this hypothesis that allowing students to access content knowledge via videos will increase overall understanding because students will be able to access the content at any time and as many times as they need. Now, it is a testable guess or question, right? It's an educated guess because I know that the more times you access material, the more likely you are to understand it. That's anyone, right? And I know that really if you're sick and you cannot access it during that sickness, but you have an ability to right afterwards, you're never going to fall behind. It helps overall understanding. Now comes time for the experiment. If you can't really set the parameters in your hypothesis, then you set them within the experiment. And you have to define the experiment oftentimes. So how are you going to test this hypothesis? I'm going to go to my video hypothesis. I'm going to test it in a variety of ways. So when students who miss class for retreats or illness or performance or games or whatever return to class, I will know these videos are helping them because they are able to better engage in the materials or in the class discussions. If students utilize the videos before a test or a retake, say you want to retake a test and you sit in office hours and watch the videos, my assumption is you will perform higher. So I can see that. That's something I can see in my experiment, something I am testing for. Now, I will be collecting data the whole time I do this experiment. Again, data can be an observation, right? I can easily observe students engaging more in class discussions, in the worksheet, and the practice problems, and say, hey, they're doing better. They're having a better overall understanding because they had missed last week, but they're still engaged in the content. I can also collect quantitative data by physically getting your retake scores, right? You'll retake an assessment, and I can see very easily, is there an improvement or has there been a drop in their understanding? Now, after collecting the data, which would be across all of my periods, so I'd have 3 periods of data to collect from, I have to analyze that data. I can't just choose one person and say, oh man, Brandon's done so well on his retakes from watching the videos, this must be working. That's not how that works. You have to look at the data as a whole. So I could say, man, all of my 2A improves dramatically after they watch the videos and do a retake, but my 3B class just keeps dropping, right? It's figuring out what your data is actually telling you. You cannot have data and simply have it there. You've got to be able to look at it and figure out what does it mean and what does it tell you, which will then help you with our 7th step, which is kind of an intermediate step. It's figuring out, was your hypothesis supported? So if your hypothesis was supported, that's awesome. You'll go right to the next step, which is drawing your conclusion. But if your hypothesis wasn't supported, does that mean you've failed an experiment? No. All that means is that you might want to redefine your question, or maybe you conducted an experiment that didn't actually answer the question you had. So it means you might need to even create a whole new question, a whole new experiment, whatever it is, to help you understand and explain the results of your unsupported hypothesis. It's not, oh, I must stop now, I have done something wrong. It's more, hey, I need to kind of go back and look at what I was doing and see what's going on there. In drawing your conclusion, you're not just simply stating, yes, my hypothesis was supported, or no, my hypothesis failed. It's more of explaining to the reader what your experiment did and what was concluded based on your data. Now, this is the difficult part, is explaining why the data proves what it does. Drawing a conclusion is actually a pretty, not difficult, but dense part of your experiment because it involves pulling everything together and explaining to someone what every little thing means. You as a scientist might understand the data and how you analyzed it, but another person might need you to explain every little part for them. So that's your challenge there. That's the real big communication skill that will take you a while to figure out. That's probably where we're going to spend a lot of time focusing when we go through experiments. That informing a hypothesis, because your hypothesis has to be pretty solid for you to move on to experiment or even to the collection of data. And that overall is really what the scientific method is. It's these 8 steps. They do not need to be done in order, which sounds a little weird, but it's true, especially if you get to number 7 and realize that maybe I didn't form my hypothesis correct, or maybe I need to do a little bit more background research. You can jump around depending on where you are. It does not have to be done in order, but it does have to have each of these aspects within it. Now, when we start doing practice experiments in class or practice labs in class, I am not going to make you go from step 1 to step 8 all on your own. I'll help scaffold it a little bit at first. But this overall is where we are building to not only this year, but through the next 3 years of science that you have.